We're going to first start off by looking at how to add and subtract like radical expressions. Before we get too far into that, a little bit of background. A radical expression is something that has a root in it. Maybe it's a square root, cubed root, fourth root, fifth root, etc. The little number denoting what root we're dealing with is referred to as the index. Like right here, I'll use this example. I see this little index number of 3 telling me this is a cubed root of 5 in this example that I'm looking at right there, that being the index. The 5, or whatever's underneath the radical sign, is actually called the radicand. A lot of these roots that I have written on the board, you don't see an index number written there. When you don't see an index number written there, it's assumed to be 2. We call that the square root. So that was just a little bit of background. Now let's go into looking at what makes a like radical expression, and go ahead and add some radical expressions here. To be like radical expressions, not only does the index have to be the same, but the radicand, what is underneath that radical sign, must also be the same. So here, when I look at example 1 here, I have the square root of 3 plus 5 square root of 3. Again, those are both square roots, so they have the same index, and they're both square roots of 3 to be more specific, so they have the same radicand. So because of that, I can actually go ahead and add these together. I have one of them here, 1 square root of 3, I don't see the 1 written out in front, plus 5 square root of 3. If I have 1 of something plus 5 more of that, that should leave me with 6 of those. So you're just adding the numbers out front together. If that had been subtraction, then you're just subtracting. Down here in example 2, we have an example of a problem that we actually cannot simplify. With that. Here we have the cubed root of 5 minus the square root of 3. There's 2 things wrong with this. They're not like radical expressions because they don't have the same index. This has an index of 3. This has an index of 2. I can't add those together. Not only that, the radicands are not the same either. I have a 5 here and a 3 there. So because of that, I cannot add those together, or subtract those, in this case, to simplify that any further. Sometimes, maybe through a little bit of manipulation, you can do something to make the radicands the same, or the index number the same. We'll take a look at that in another example. Let's take a look at this particular problem as an example. I have the square root of 12 plus the square root of 75 minus the square root of 3. They are all square roots. They have that same index of 2, but they're still not like radical expressions the way they're written because the radicand is not the same. What's underneath the radical sign does not match. I have a 12 here, a 75 here, and a 3 there. So it looks like we can't do anything, but actually we can. We can manipulate this a bit by simplifying these first 2 radicals. If we simplify them, they actually turn into so many square roots of 3 in this particular problem, which will allow us to combine them. So I'm going to go ahead and do that now. I'm going to rewrite the 12 as 2 separate square roots that would multiply to give me 12. One of those will be 3, as a matter of fact. So 4 times 3 is 12. So I can separate that as the square root of 4 times the square root of 3. 75, I can do something very similar. 75 is 25 times 3. 25 is a perfect square. So I'm going to separate it as the square root of 25 times the square root of 3. And then I just have minus the square root of 3. Now, continuing to work with this, the square root of 4 is 2. So this just becomes 2 square root of 3. We looked at a more visual factor tree method earlier in the school year on how we can break down the square root of 12. I mean, feel free to use that if that was what helped you. But we simplified the square root of 12 to 2 square root of 3. Doing the same thing with 75. Here I have the square root of 25 times the square root of 3. The square root of 25 is 5. And then the square root of 3. And then lastly, bring down this minus the square root of 3. Now, these are like radical expressions. I have 2 square root of 3, plus 5 more of those. That makes 7 square root of 3. Finally, minus the 1 square root of 3 here, which should leave me with 6 square root of 3 as a simplified version of this radical expression.